All right, today we're going to do some word problems involving perimeter and area. It says a rectangle has the perimeter of 40. Write the dimensions and areas of 3 rectangles that fit that description. Okay, so I think it's easiest if we draw stuff out and kind of see what the heck is going on. So let's say I make my widths 1, okay? If the perimeter is 40 and you've already used 2, that means you have 38 left to use. So 38 divided by 2 is 19 and 19, right? Okay, and remember, perimeter is the distance around. So 1 plus 19 plus 1 plus 19, that equals 40. Okay, let's try again. And again, I'm just getting some basic numbers so that you can see. So now what if our width is 2? So we've used up 4. So 40 minus 4 is 36. Now let's divide that by 2. And we'll have 18 and 18. Again, just showing you some basic ones so you can kind of see that there is a pattern. So now let's do 3. What if your width was 3? So that means out of 40, you've already used 6. 34 left. We're going to divide that by 2 and get 17 and 17. Let's stop there, okay, because you should be able to see the pattern. What is up with the length and the width? The length and the width, the length and the width. What's up with them? What's 1 plus 19? 20. What's 2 plus 18? 20. What's 3 plus 17? 20. And if I did 4, it'd be 4 plus 16. 20. 5 plus 15. 20. So we know the length plus the width is going to give us 20. Okay? So we have a perimeter of 40. 20 is what it's going to add up to equal. What's up with the 40 and the 20? Yeah, they're half of each other. And again, we're developing these patterns that we're going to see. That's going to help you write the equations for all the problems. Let the length of one side be x. Then write the function a of x that represents the area of the rectangle. So we want to keep length in the equation. So we're going to solve this guy right here for w. So if I was solving for w and I wanted to move this L to the other side, he's positive here, so what will he be over there? Negative. So I know w is equal to 20 minus L. Now, they want us to change the L to an X. So W is equal to 20 minus X. See, they say it right here. Let the length of one side be X. Okay, got it. Now we're going to do the area, A of X, which we know is, area is length times width. Okay, that's what it is, length times width. Well, the length, they asked us to write X there. Width, we know it, it's right here. W is equal to 20 minus X. 20 minus X. Now let's do the distributive property. X times 20 is 20x. X times negative x is negative x squared. All right, there it is. There's our equation for area. So now we're going to graph it. I'm going to move my graph over so you can actually see. We got to label our axes first. So the x does represent the length. Again, it told you that in the problem. The y is representing the area. And I'm just going to call our guy title. I'm just going to call him rectangle. Okay? So we always want to make sure that we're labeling everything. Now, down here, I think I'm going to count by, what are you guys thinking? You want to count by 2s? 2, 4, 6, 8, 10, 12. 14, 16, 18, 20. All right, so counted by 2s down there. Okay, I don't know. Let's make the area, you know it's going to be bigger than the length. So maybe counting by 10s. 10. And you can always use your calculator to kind of get a better answer to what you want to count by. But I'm thinking this is going to be okay. So I'm going to move my calculator over here. I think I'm just going to do kind of every other one. We know if we plug a 0 in here, we are going to get 0. So I'm just going to put a dot there. So let's maybe try the 2. So I'm going to just plug the 2 into our equation right here. 20 times 2 minus 2 squared. All right, that's 36. So about here. Now let's do the 6, because I'm just going to skip some. I don't need 2 million dots, okay? So let's try the 6 now. 20 times 6 minus 6 squared. 84 A little bit more. All right, let's try the 10. 20 times 10 minus 10 squared. All right, 10 is right at 100. Now let's go down a little bit. Let's do 14. Because again, I'm just getting some dots so that I can get them on my screen. So 84, see how I'm kind of going back down? So I've came up, now I'm going back down. Let's do 18. 20 times 18 minus 18 squared, 36. And then I bet you when I plug this 20 in, I get 0. 20 times 20 minus 20 squared, 0. Yep, there's my parabola. Now, why do you think that this graph looks like this? It's only showing that first quadrant. Can your length and your area be negative? No, they can't. That's why we're only in the first quadrant. All right, let's try again. Let's use the patterns that we have discovered to try again. What do you think? Now, this one was a perimeter of 40. Now I'm going to try a perimeter of 80. What do you think the length and the width is going to add up to this time? What do you think? Make an educated guess, and then we'll do one. Okay, so you keep your educated guess to yourself. And I'm going to do 2 and 2 as my length. This time we have 80. So 80 minus 4, because we've already used 4, divided by 2. So we get 38 and 38. Okay, so let's add our length and our width. What did we get? What's 38 and 2? 40. Did you guys get it right? I don't know, but remember, it's always half. Okay, so this one was length and width added up to 20 because your perimeter was 40. This one, your length and width add up to 40. Your perimeter was 80. So remember, we are going to solve for the W, so 40 minus L. And then when we write our equation, A of X, we know we're going to do length times width, but they want the length to be an X. So X is length. Your width is 40 minus your length. And then you just multiply, distributed property, 40x minus x squared. All right, there it is. And then you're going to set up your graph the same exact way. Do not forget to label your axes.